Hi guys, and welcome to today's math lesson. So we're still working with fractions. Today we're going to be identifying fractions that are actually equal to a whole number. So our learning target is I can identify fractions that are equal to a whole number. Our success criteria are that you understand in order to put a fraction into a whole number, you divide the top number, so the numerator, by the bottom number, which is the denominator. You also understand that in order to turn a whole number into a fraction, they need to put it in one. So that means if I have a whole number of, let's say I have a whole number of 3, in order to make 3 a fraction, I would just put it over 1, meaning each circle is one piece, and I have 3 of them, making 3 wholes, okay? And then student can correctly identify fractions that are equal to a whole number. So again, if I'm given, let's say, well, we'll get into it. But if I'm given that 3 over 1, I need to be able to say that, hey, that's only worth 3. That's worth 3 whole, okay? So, again, your learning target is I can identify fractions that are equal to a whole number. So some things you need to remember or know from last time are what a numerator is. My numerator is my top or bottom number. Figure it out. Think to yourself, which one is it? Numerator, is it my top or my bottom? Hopefully you said it's your top. Also, tells you right here. And that's the number of parts I have. I have 2 parts, okay? And then the denominator down, that's my bottom number, right? And that's the total parts that the whole piece is cut into. So if I have a cake, right, I cut it into 5 pieces, and according to this fraction, maybe I ate 2 of those 5 pieces, okay? So sometimes fractions, though, they aren't always up and down. Sometimes they're more side to side, and you still need to be able to identify the numerator and the denominator in those fractions, especially for today's lesson. So let's look at this first one. It's 2/5 again. Go ahead and see if you can figure out which one's the numerator and denominator. This one should be very simple for you because, hint, hint, the answer is on the screen. Okay, so the 2 is the numerator, right? And the 5 is the denominator. Let's go ahead and let's try that again, but with the one that doesn't have the answer literally on the screen. I have 7/10. Go ahead and try to figure out which number is the numerator and which number is the denominator for that one. Pause the video if you need more time. You should have said, well, the numerator is 7 and the denominator is 10, okay? And that's because the denominator comes last. So again, if I'm writing a fraction, I usually write the numerator first and then the denominator last. Same thing if I were to write it side to side. I would write the numerator first and the denominator last. It's just a way for you to kind of remember. Okay, so again, I'm still working on identifying these fractions that are equal to a whole. Fractions, they can be like people. We have those who act proper and those who do not. And proper means good manners. So think back to like Thanksgiving, right? Did you have that like crazy uncle, or maybe it was your brother or sister, that was burping at the table? Well, they don't have good manners, so then they're improper. Maybe you have that aunt or your sister, or maybe you have good manners, so you're very proper. You did what you were supposed to. You cleaned up after yourself. You weren't burping at the table. So that is one way to think of fractions. A proper fraction knows that the numerator, so the top number, is supposed to be smaller. So it knows that the denominator is supposed to be the bigger number. But we have other fractions. Oh, let me give you an example. Like 2/4 here. 2/4 is a proper fraction, meaning the numerator is smaller than the denominator. But then we have other fractions. They're called improper fractions. They don't care about the rules. So they look a little different. They have a bigger numerator than they do a denominator. So this guy has 10/2. Normally, we would see it the other way, right? But this is saying out of a shape that's cut into 2 pieces, we have 10 pieces, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we have fractions like these, we often can turn some of these fractions into whole numbers. You'll notice, how many circles do I have in total? I have 1, 2, 3, 4, 5 circles. So 10 over 2 is the same as, or 10 halves is the same as 5. So today we're going to be turning some of these improper fractions into whole numbers. So they won't be fractions. Some of them, most of them actually, all of them today. But in the future, some of them won't be fractions anymore. So sometimes when we do this, we'll just get a whole number and we'll move on like we are today. Other times we'll still have a fraction connected to it, but we'll get into that another time. But anyways, so when I'm working with these today, I'm going to take a fraction and I'm going to turn it into a whole number so it's proper. So it won't be a fraction anymore. It'll just be a whole number. It'll look a lot nicer. So we're going to try that, okay? And I know some of you are probably already like, what is she talking about? Just stick with me. I got you, okay? So how do I know if a fraction is actually a whole number in disguise? Well, I divide the top, the numerator, by the denominator, okay? So I'm going to divide the numerator by the denominator. So that means for here, I have 4 over 2, or 4 halves. I'm going to do 4 divided by 2, okay? And from there, I can decide what whole number that actually is. So 4 divided by 2, 2 times 2 is 4, so it must be 2, okay? So 4 halves is actually the same as 2, and let's check this out, okay? 1 half, 2 halves, 3 halves, 4 halves. Well, I have 2 whole shapes colored in, so therefore, yeah, it is equal to 2. Let's go ahead and let's look at this one. It is 8 halves, okay? So again, I'm going to just divide the numerator by the denominator, so 8 divided by 2, okay? And it's really important that you do know which one's which, because if I did this, it wouldn't work. That's not going to work. So make sure you know which one's the numerator and which one's the denominator, okay? So 8 divided by 2. 8 divided by 2 is, well, 2 times 4 equals 8, so it must be 4. And again, I could draw a picture and double check my answer, but I know that that's correct. So you guys are going to do the same thing, okay? So you're going to try this with me. You're going to try to turn these fractions into whole numbers. So the first one is 7 over 1. So I simply am going to divide the numerator, by the denominator, okay? So my numerator is 7, and I'm going to divide it by 1. Go ahead and write that down if you haven't already. And then think to yourself, what is 7 divided by 1? Okay, you should have said 7 divided by 1 is 7. So there's my answer. 7 over 1 is the same as 7. And honestly, this one's really nice and easy because I know if I do any number over 1, it's going to be that number, okay? So if you see one like that, it's really nice and easy. It goes both ways, okay? So if you ever need to turn a whole number into a fraction, you just put it over 1. So now let's do 12 thirds, okay? So think to yourself, which one's the numerator, which one's the denominator? Use this little guy right here to help you out. Set up your equation. Hopefully you did something like this, right? And then now I just need to figure out what 12 divided by 3 is. So go ahead, pause the video, and think, what is 12 divided by 3? 12 divided by 3 is 4 because 3 times 4 equals 12. So my answer is just 4. Okay, let's do another one. So I have 6 over 3. Go ahead and use that numerator divided by denominator to help you out. Create your equation. Okay, your equation should look something like this. And now pause the video and think to yourself, what is 6 divided by 3? Well, 2 times 3 equals 6, so my answer is 2. Okay, this next one, again, we're going to be using that same setup here, okay? Numerator divided by denominator. So you're going to try these first. So I want you to try using that numerator divided by denominator to figure out what 20 tenths are. What number is that in disguise? Pause the video if you need more time. Well, you should have said 20 tenths. 20 divided by 10. Well, what times 10 equals 20? 2. So 20 tenths is actually 2. It's funny because it looks like it would be a really big number because of 20, but it's actually not a big number at all. It's only 2. It's 2 whole. Okay, let's do the next one. 21 over 1. Go ahead, pause the video, and see if you can use the numerator divided by denominator setup up here to figure out what number that actually is. What whole number that is in disguise. Okay, hopefully you're done now. If not, again, pause the video. 21 divided by 1. Okay, and I know this because, again, this is my numerator, this is my denominator. Okay, so 21 divided by 1 is going to be 21. Okay. So, and again, the nice thing is if anything is over 1, you just know it's going to be whatever the numerator is. And same if I want to turn 21 into a fraction, I would just put it over 1. Okay? So go ahead and try this last one. See if you can figure out what whole number in disguise 16/4 is. Pause the video if you need more time. You should have created an equation like this, 16 divided by 4. Then you should have thought to yourself, what times 4 equals 16? 4. Okay, so then 4 is your answer. Okay. Now, this is your exit ticket. Be sure to use this format in order to help you out. Numerator divided by denominator. Okay. But you are going to use that to solve 60 tenths. 3 over 1, and then 15 thirds. When you're done, make sure you Zoom us. This is important because we do want to see how you are doing. If you have any questions or need any help, please reach out to myself or Mr. Davison.